Hello everyone, welcome back. This is Mr. Hossein Wasapi, and in this video we'll be going through a revisional problem that involves derivation. So as you see from the question, it reads, from Newton's second law and with the aid of the schematics, derive the principle of impulse and momentum. So this is an open talk video, so let's begin. So how to go about this is quite easy, I would say, but if you don't get it right, but you can remember that with a little bit of practice and perfection you'll get a hang of it. So now we need to understand this. From the second law of motion, we know that summation of the forces is equal to what? Mass times acceleration, where we understand that acceleration is the change in velocity over a period of what? Time. With this in mind, we can substitute for A with what it represents. So we say that the summation of all the forces is equal to m times what A is now, which is dv over what? dt. And this will be the summation of the forces being equal to m dv over dt. Once you reach this point, all you have to do is to multiply throughout the equation by dt. By doing that, you have the summation of all the forces, dt, being equal to the dt here will cancel out the dt there, and that will cancel out, and you just have m dv. After that, you will take the integral of the left, so you integrate the summation of the forces, dt, being equal to the integral of m dv. So this one will have the limits of t naught and t final. Same thing here, v naught and v final. So upon doing that, you will have the integral of t naught and t. Summation can be plugged out, and you have force times what? dt, being equal to, if you integrate the right hand side, this portion here, you have mv at the point of v naught and v. Once you do that, you end up having the summation of the integral of t naught and t of f dt being equal to, if you evaluate this portion here, you have mv minus mv naught. Now this portion we're having here is called impulse, and the other point here that we have here is called momentum. So the summation of all the impulse is equal to the change in what? Momentum. Now if we manipulate this equation, we'll have take the mv naught on the other side, this portion here, we'll have mv naught plus the summation of the integral of t naught of t of f dt being equal to m what? V. And this is the principle of impulse and momentum. To easily understand this, we can use a schematic. Say you have a particle here. Let's say it has an initial momentum of mv naught. Say the same particle receives forces or impulses from different directions. You'd find that as a result of these impulses, you will end up having a different momentum, which is a change in momentum, which will be mv. And this is a schematic you can use under the derivation. So let us understand clearly that this is how it actually works. So since it's an open talk video, I'll ask other people who have questions to reach me on WhatsApp on the number that's attached to the screen. Alright, thanks for watching. This is Mr. Osem Wasapi. Don't forget to like and subscribe. And remember to strategize before you become a statistic. And let's try to push for that A+.